apply some of the vector stuff we've done with a couple physics applications. One's going to be projectiles, where you launch something and see its path. We're going to use a baseball. Another one's going to be tension, when you're pulling on a cable or rope, how much force is stored in that rope. So the first one here, a ball is thrown with initial velocity at 93 feet per second, angle of 42 degrees with the ground. Find the vertical and horizontal components of the ball's velocity. All right, so eventually we're going to get into what's called parametric equations, and you'll be able to graph the entire flight of this ball. And here's a preview of what that's going to look like. So what's going on here is I've got the path of the ball. This is its initial direction. And then, of course, it starts to gravity takes over, it slows down, and kind of makes a parabola curve. Now I've got it going really slow so we can see what's happening. I'm looking for the horizontal velocity, so I'm going to put Vx, velocity in the x direction there. And we'll do the similar thing there. We'll do the velocity in the y direction in a few minutes. All right, so if I want to figure this out, again, I've got an angle, hypotenuse, and I have an adjacent side. So I'm going to set up a cosine. Cosine 42 is Vx over 93. And you can keep units or just leave them out for now if you'd like. So 93 cosine 42 degrees. That is my x velocity. So make sure you are in degrees. Cosine, or 93 cosine 42. That's 69.1. So if I'm going 93 feet per second altogether, because of the angle I hit the ball with, it's 69 feet per second across the ground. Now, if you think about a shadow maybe vertically, so maybe it's like a light way out in the field or something, and we're kind of watching the ball go up against the backstop, something like that. So eventually it goes up and it comes back down, but really at this point, all I want to look into is how much speed is it going up with when it first takes off. So that's for now what I care about. Now later we'll incorporate gravity into all this and factor in everything. So if I want to figure out that vertical piece of this, relative to the angle, that is opposite. So I'm going to set up a sine relationship. So 93 sine 42 should give me my vertical velocity. So about 62.2. And there you go. That is your horizontal component and your vertical component. The only thing really left, if we want to write this as a vector in component form, then this is our x, so 69.1. This is our y, so 62.2. And that's probably about as far as we could take. All right, now we're up to tension. This is probably going to be one of the more challenging things you do, but once you get the hang of it, it's really not too bad. Just a lot of things to keep track of. So we have two cranes. They're lowering a 2,000-pound beam into place to build a bridge. Before I read any further, I'm just going to let you kind of look at the picture here. This is really something that happens in construction. You get a crane on either side because it would be really difficult to put something in the middle to pick up this beam. I mean, you've got a big gulf between, we're building a bridge across. So if each crane gets a cable on here, they can both pull and they can basically maneuver this thing anywhere they want to go. We can't pull but so hard. If tension gets too much in one cable, it's going to break. And when a cable snaps on a crane, that's bad news in a lot of ways. So this is really something you'd have to be careful about if you were doing this. So if the tension becomes too great, it's going to snap the cable. So use the diagram below to figure out how much tension is in each cable. All right, well, this one is maybe further away from what it looks like in the diagram, so it's at a little bit of a shallower angle, almost horizontal. It's only pulling 10 degrees. This one's pulling 37. And the beam is 2,000 pounds. So what you want to do is draw out the situation as simple as you can. Now, when you take physics, you'll hear about a free body diagram. We're really just looking at all the forces happening right here at this point. That's what this square is going to represent. Because that's where really everything's happening. Now, right now, everything is just sitting still. Everything's in balance. Nothing's moving yet. Now, once you have an imbalance in forces, that's when things start to move or accelerate. For now, everything's just sitting still. All right, that makes it a lot easier to calculate. So everything's sitting still. This beam weighs 2,000 pounds, so gravity's doing its thing. And we're definitely getting some downward force of 2,000 pounds. Well, let's think about what the cranes have to do to keep that beam from falling. They have to pull up with exactly 2,000 pounds as well. Now, before I write 2,000 there, I'm going to define that a little better, but I'll come back to it. Now, the beam, these cranes are playing tug of war with each other. They're pulling in different directions, but the beam isn't moving, so they're exactly balanced. So, however much pull you have in this direction, it's got to equal how much you've got in the other direction. Okay, these two are equal. So I'll just kind of put a note there that those are equal, horizontal. All right, and technically these two are equal as well. Now, let's start thinking about tension. So now we're going to move on to setting up some trig. So this is 10 degrees. And let's probably call this tension 1, tension 2. It really doesn't matter. That's the amount of tension in that cable, that's the amount of tension in that cable. Well, I'm going to do components just like I did with the baseball. So this will be my x1, this will be my y1, just to make it simple. X direction for the first tension, y direction. I'm calling this tension 2, I'm going to call this x2, y2, just to keep it simple. Okay. So before we put any trig into this, let's do this free body diagram, fill it in. Let's do it in terms of what we came up with so far. Now in the x direction, these two are equal. So x1 and x2 are pulling at the exact same amount of force, just in opposite directions. Now 2,000 pounds, think about what's doing the lifting. Both cranes are sharing the load when it comes to lifting this thing up. So y1 plus y2 together has to be your 2,000 pounds pulling down to equal it out. And what you're going to find with these physics problems is they can all be boiled down to something fairly simple like this. And as you substitute more and more things you know in, they fluff up. Now, I'm not going to say they get more complicated, they just get fluffier. They get a lot more pieces in them. So we do need to start, if we're going to work toward an answer here, we do need to start trying to figure out what these things are. So let's come up with some trig equations that would describe the situations we have. All right, well, let's maybe just start with x1. All right, well, x relative to this angle, which is right here, x is adjacent. And we really don't know the opposite or the hypotenuse, but it's really best if you do everything in terms of the hypotenuse so it's in common later on. And I think you'll see what I mean later. So I'm going to do a cosine relationship. Cosine of 37 is x1 over t1, which means that t1 times cosine of 37 is x1. Now I'm going to kind of set up a chart, a four-way or four-piece chart here. It's not truly a chart, but something similar to a chart. For y1, x2, y2. So let's move on to let's do y1. Well, if I was going to solve for y1, I want to do a sine relationship. It's going to be pretty similar. It's going to be t sine 37, t1 sine 37. If I want to figure out x2, set up your cosine relationship. It's going to end up being t2 cosine of 10. And y2 is going to end up being t2 sine of 10. So those, so it's kind of like a chart. There's about four equations that are really help me figure out the tension. Now, if you know the process we've talked about all year. However many variables we have, that's how many equations we've got to have to solve them all. So far I've got 4 equations, but I've got 6 variables. So I need 2 more equations, and those are going to come from this free body diagram. So things I know to be true. I know that x1 and x2 are equal. So I'm going to take x1 and x2 and set those equal. x1 has to equal x2. And by substitution, x1 is t1 cosine 37, x2 is t2 cosine 10. Something else I know has to be true is that y1 plus y2 equals that 2,000 pounds. All right, so here are my 6 equations. I got 6 variables, 1, 2, 3, 4, 5, 6 equations. So we should have everything we need to finish solving now. And again, I'm going to substitute. Y1 is T1 sine 37. Y2 is, I forgot equals there, T2 sine 10. And that equals 2,000. I'm not going to worry so much about units right now. I will at the end. Okay, well at this point we've got T1 and T2 in both of these equations. So we could go either substitution or elimination, or if you're really clever, you can do matrices. But I'm going to go ahead and do a substitution here. Completely up to you. I just feel like substitution is the easier way to go. And it really doesn't matter which one I solve for. Solve for T1 or T2 and then plug in the other one. Looking at T1 first, so I'm going to solve for it. T1 is T2 cosine 10 divided by cosine 37. All I really did was divide cosine 37 on both sides. Okay, now that I know that to be true, I'm going to plug it in over there. So T2, instead of T1, we'll put T2 cosine 10 divided by cosine 37. And that is multiplied by the sine of 37 that was already there, plus T2 sine 10 equals to 2,000. Okay. At this point, I'm going to move on to the calculator, because really, since both of these are T2, and all your cosines and sines of angles, they equal some decimal ratio, some decimal number. So really, this is some decimal times T2 plus some decimal times another T2. They can be combined, like terms. So what I'm going to do in the calculator, I'm going to attach T2 at the end, but I'm going to divide these, multiply by sine 37, and add sine of 10. If I factor T2, you know what, I think I'm going to do that. I'm going to go ahead and factor T2 out, just so it's really clear why I'm doing what I'm getting ready to do. There's a lot going on. So I'm taking T2 out of this term, times sine 37. I'm going to make even bigger brackets. All right, took T2 out of all that. I'm going to take a T2 out of this part. So there we go. T2 came out, so I'm going to divide those, multiply by sine 37, add sine 10. And then I'll be able to solve for T2. All right, if you kind of notice my progression here, I broke it up into 3 steps, because I don't want to make a mistake with parentheses or something like that. So I did cosine 10 divided by cosine 37. Then I multiplied, then I added, and I've got this decimal. So what I'm getting now is, and I'm going to abbreviate this really bad, T2 times 0.9 is 2,000. Now, I've got all those decimals saved in the calculator. All I got to do now to solve for T2 is divide off that 0.9. So let's do that. 2,000 divided by this answer. We're getting about 2184. So the tension in line 2, or cable 2, is about 2184. It really doesn't matter which one I call T1, T2. When you go back to the diagram, you can see which one you labeled which. So the tension in that cable right there is 20, whatever I said it was, 2184. Yeah. And then I've already rearranged for T1 over here, so that shouldn't be too bad. This is hopefully kind of the easy winding down part. I put in 2184 here, and just plug it in. So I just took that answer, multiplied by cosine 10, and then divided by cosine 37, kind of broke it up in separate steps. So 2693 is the answer for that one. So T1, about 2693. And I guess I should be putting pounds because that's what the tension was measured in. And just kind of the last thing to show you before I end the notes here. On your assignment, I included this tension solver. So I made this up a couple years ago, and all you got to do is just type your angles in and your weight. It says enter known values, and it answers everything for you. So as you're doing these homework problems, I know there's a lot going on, and especially if there's one that give you an even problem, so you want to check the answer. Just put your angles and your weight in there, and it'll show you the tensions you should be getting. And also, tension 1, at whatever angle you put on this side, that's the tension that goes with that angle. So that's how you keep track of which side you're looking at.